All right. Well, I appreciate the opportunity here. I just make sure everybody can see my PowerPoint.
Yeah, it was good.
All right.
Hey, can you hang on 1 second, Steve?
Sure.
I hate to slow you down there, but I'm having a recording problem. Let me see here. All right, I think I got everything going with the recording, so Steve, we're ready to go anytime you are.
All right. Well, just so everybody knows, my name's Steve Jackson. I'm with NB West Contracting in St. Louis. My background is right here. I've been around shingles for about 8 or 9 years now. We started when I was at Pace Construction. We did the first shingle jobs in Missouri. So I've got a little bit of experience with it, and I will give you some of the pros and cons that we've ran into for over the last 8 or 9 years. When I'm talking about shingles, I always want to make sure that everybody knows what we do in Missouri is residential tear-offs that are stockpiled and then ground later. We do have a couple shingle manufacturers in Missouri, but there's not enough for the amount of shingles that we do. So we are taking shingles right off the roofs. So that's what we're doing here. Got a little echo here in the.
I think I got that fixed. I had to mute
Okay.
Richard Willis. He just logged on, but we're good to go now. He just won't be able to ask a question, so he's going to have to chat it to me if he has one.
All right. So in 2003 is really when I started getting involved with this. They came to me and asked my opinion if I thought we could put shingles in asphalt and make it work, and I said no. They said we're going to do it anyway, so sometimes you end up being wrong about things. But in 2004, we started doing some at Pace. We started doing some pilot projects, and I'll show you one or two of those as we get going along here. And then from there, MoDOT really jumped on board with shingles. And then in 2008, when the high oil prices hit, all the contractors basically switched over to using shingles. This was, Buzz was telling me about you guys are looking at doing a test section along a quarry road. Well, that's what we did with shingles. We started paving the quarry roads where we had a couple plants. So this job we put down in November. It was the day before Thanksgiving in 2004, and this quarry road gets quite a bit of traffic. A lot of the trucks. This is in a what they call a heavy commercial zone. So a lot of the trucks coming out of here are 80,000 pounds plus. This road also goes underwater a couple times a year. It's right along the Merrimack River. So high traffic, lots of moisture, and it's still holding up very well. This was the first MoDOT job that we did. We put in, looking basically at a binder course or an intermediate course, and we tried it with several different oils. One of the concerns that we've always had is with the shingles, making the bottom end. We're right at a 6422 on our climate data for using our ACs. So anything that we put in there that brings that minus 22 up, we've got some concerns about fatigue cracking and cold weather cracking. So we started off trying 5828. The downside of that is it's not locally available in St. Louis. So anything with the minus 28 cost a lot more. So we have to get either from the Kansas City or Chicago. So That job went off very well, had a lot of interest in it, and I went down in January and looked at it, and it's still performing very, very well. So just to give you an idea, this is the shingle usage. In 2005, that 20 tons of shingles was on that project I just showed you. In 2009, that bar there, 53,000 tons, that was through like September. We wound up around 70,000 tons of shingles in 2009. And then 2010, we were around 80,000 tons of shingles used statewide, and that's just on MoDOT work. And for a total estimate, there were about 118,000 tons of shingles that were used in Missouri that year, according to the Napa did their RAS Wrap and Warm Mix survey last year. So I asked Joe Schreier at MoDOT, and the 2011 number is pretty similar to 2010 there. So there are a lot of shingles being used in Missouri. We talked about why we're using this. We get this a lot, but basically it comes down to that second one, reduce cost. With the contractors here, that's what they're looking at. So, and it depends on your area. Some places that we operated in when we started out, we were able to collect tipping fees. We cannot permit new landfills in Missouri. So this was one of the other driving factors behind shingles. So at first we were able to charge tipping fees. Now there are so many people doing shingles that basically we'll accept them for free. And at some places they've already said they don't want any more shingles taken in. We had the Joplin tornado, and then we had 2 tornadoes that hit St. Louis. So right now there is a surplus of shingles on the market. So that's one of the pro about doing this is that right now you can buy a load of processed shingles for about $20 a ton. The other thing you have to be careful of is solid waste permits. In Missouri, the only thing that we have is if you have to use it within a year of collecting it. So anytime that we get shingles in, we have to grind them and use them. If we store stuff on site for more than a year, then we have to apply for a solid waste permit. So that's one of the reasons also that people aren't accepting all the shingles that are available right now. Some of the commercial places in St. Louis and around the state, they have a solid waste permit, so they grind shingles year-round. So the benefits of it is, like I said, in the cost. We always have this debate on how much of the shingles is available for use. Basically, my thought is 70 to 75% can be reclaimed out of the shingles, and I have 30% recycle on there as what's our oil is available, or what's in the shingles. Sometimes you'll get numbers back on extractions that are 22, 23, and they go up to about 30. Most of the times we get them back there in the 27 to 28%. So 75% of that, you're around 22% reusable asphalt. So putting 4% shingles into a mix will save you about 0.9 to 1% in virgin asphalt. So you can see the savings there based on the ton of asphalt cement. It appears that 2012, it looks like oil prices in our part of the world are going to be up again. So that number will change with the asphalt price. One of the big things that is associated with the cost of this is the grinding. So the grind size is very important, and I'll talk about that a lot here in the next few slides. But the more you grind it, the more it's going to cost for your grinding cost. The other thing is the cleanliness of the shingles. Moisture is a big one. You do need some moisture as you're processing the shingles to keep the dust down and to get a proper grind. And the type of grinder that you're using is also variable in the cost. What we've done in Missouri is there's been a few people that have gone out and bought their own grinders. What we do at NB West is we actually have a company come in and grind for us, and they charge us, so much per hour to grind shingles. So the other thing is if you've got multiple locations, if you've got to haul shingles in, grind them in one spot and then move them to another plant. There's some cost associated with that. So this is the grinding operation when they come into our plant. They set up and grind shingles, and then we run them across our scale and stockpile them. And we typically try to do that in March or April. One of the big things here on shingles is the moisture. A ground shingle will run in that 12 to 15% moisture. So you've got a lot of drying cost associated with them as well. That stockpile stays wet, so if you can cover them, keep the rain off of them. The other thing is we store ours on a sloped area. We've paved all of our lots at our plants to get the water out of our aggregates and especially our wrap and shingles. So high maintenance. When you start running shingles and wrap in high percentages, you're running your virgin aggregate temperature way up to dry out your wrap and shingles. What we found is we started cracking our tire on one of our drums at one of our plants, and I'll show you a few pictures of that. But that's one of the things you gotta be worried about. So we switched over to warm mix and to try to lower that temperature down and help preserve our plant a little bit. So one of the things, if you're getting into this on the professional level or on a commercial level here, is you're going to have a lot of different mix designs. We used to make virgin mixes, then we started making wrap mixes. Then most of the time, the mixes we design now have both wrap and shingles in them, just depending on our usage. A lot of times, depending on the availability at our plant, we'll either run just a straight shingle mix or a straight wrap mix, depending on what we have the most of at the time. So if you take all those mix designs and then you also have to come up with warm mix designs, that's quite a bit of a few mix designs that you have to do at every plant for every situation. So there is a cost there for doing the mix design, as well as quality control testings. You got to run extractions. That's what the Missouri Department of Transportation expects of us, is we have to provide them with extractions from our materials, and then we also have to come up with the gradation. And depending on the type of contract, what type of mix is being laid, we might also have to come up with correction factors for our shingles and wrap to do the quality control aspect of it in the field. These are the covers that we built over our shingle piles. They're fairly simple to put together. One of the other things that the covers do is if you grind your shingle down very fine and you get into July and August and it hasn't rained in a while, well then if the wind starts whipping through your stockpile there, you actually start losing shingles because they're blowing away, not just from the moisture and everything. The other thing that'll happen in the summer with that moisture in the shingles is sometimes the surface of the pile will crust over. So you have to make sure that your loader operator peels that crust off and then break that back up and then gets back into the shingles that are ground. So that's one of the issues as well. This is our sloped stockpile. The pile on the left is shingles. You can see how much water is draining out of that. Very, very important to make sure that you have some kind of system set up to get your shingles, keep them dry. This was the tire that I was talking about on our drum. This is a standstill plant, and it has a solid tire there that's directly connected to the drum. That heat just went straight into the tire. All those bars that you see on the left and right of that tire, we added those after this broke the first time. So that tire snapped and it moved off to the right just a little bit, about an inch and a half. So we had to put all those bars back in there to hold it and to get it back in place to weld it back together. So this happened twice that year, and we had it happen once the next year, and then we decided that we needed to switch over to warm mix if we were going to run a high percent of wrap and shingles. That does not occur on every type of plant. Like I said, this is a steel-on-steel conduction of heat right through there, so If you have that type of plant, it may be an issue. Some of the tires that have got the spacers or have spacers in there won't let that heat go right through to the tire. This is us putting it back together. We had to cut it and then build the weld back up. It's kind of funny because this is always happens on the back tire. You'd expect it to. This is a counterflow drum, so we'd expect it to happen probably more on the front, but it actually happens on the back. I don't know if it's just a weaker tire or what it is, but we had to build that back up. And this particular tire's got 3 of these cracks in it right now. On the left here is our auger that returns the dust back into our drum. This plant has 2 drums. There's one to the left, and then we feed the dust in here, and the second drum is our actual mixing drum, and we return the dust there. And to the top right of the picture is our conveyor belt that feeds our wrap and shingles in. This area has been problematic for us because the moisture in the shingles and wrap hits the shingles and wrap hit the hot aggregate coming out the other drum, and it steams up. And then when we're feeding the dust in, we create kind of a mud inside the plant. So this is the looking down into that throat going into the drum. You can kind of see a little bit of buildup in that top right corner, and that's what happens. That builds up and it plugs up that chute, and then we have to get in there and clean that out. So this is kind of looking down the conveyor belt from the wrap and shingles coming into that chute. Let's see if I got what we did is on that previous slide, we went back and we created a clean out slot below that, and we were able to get in there and clean it out. Long term, what we've done is we have put on some additional duct work, and we are sucking that moisture out, and we have about 100 foot of pipe or about 150 foot of pipe that we suck the moisture out and collect it in a tote, and then we can keep that moisture from building up in our plant. We used to have just kind of water running out of the bottom of our mixing drum, and now we're pulling all that moisture out. We are not getting this buildup over here on the right, and we're able to run nonstop. Before we put the system in to suck the water off the drum, we were getting about once a day where we'd have to shut the plant down and clean this area out and then start back up and go. And since we put this piping system in, we're able to run all day with no issues. So one of the things I'd like to show you there too is we have on this picture, kind of right in the middle, those blue tarps. That is our wrap gator deck and our scalping screen. So we have a little gator crusher up on top that kind of makes sure we don't have any oversized material getting in there, and then it goes down and hits a scalping screen. So if there's anything very large, it falls off the back. But this particular plant sits down in a valley, and the wind comes straight up this conveyor belt, and we get a lot of shingle dust or the fibers blowing around. And the plant operator here is very, very susceptible to the shingles causing him to itch. So what we've done here is we put these tarps around there, and now we put plates around there, metal plates as well. But that's one of the things you got to consider is you're probably going to have somebody that is going to have a real issue with the shingles. We make sure that we provide our people with respirators if they're going to be working around this as well. When this stuff gets in the air, especially during the grinding, I mean, you can just see it floating around. So that's one of the issues you got to be aware of. What we've done here as well is put these covers on our conveyor belts to keep the wind from blowing the shingles around, and that has definitely cut down on the irritants that are flying around. So that's just the other end of it. Like I said, we've gone and put plates on there now and taken the tarps off and keep all that contained. One of our other plants, we had a collar on there, a wrap collar, and we were feeding the shingles and the wrap into this one collar. That will work for small amounts of wrap and shingles, but once you start trying to put, around 30% total, between the two of them in there, we started having issues with the shingles plugging up this collar. And it clogged up about every 7,000 tons, and there's no way to tell what was building up in there. So we get to the point where it would quit feeding through this wrap collar, and when I say it builds up, we had to jackhammer it out. So we were down for like a week jackhammering this out. Got it going again, about another 7,000 tons, it clogged up. So at that point, we realized we needed to do something different. So we quit running shingles out of that plant that first year, and I believe that was in 2008. What we went to is we created a chute here that feeds the shingles into the drum now, and this is able where the ground man can climb up there and see how it's feeding, and if we need to scrape this down. This has been an issue on shingles since we started back in 2004 on the plant. When I was at Pace, we had a gin core plant, and it was kind of feeding like this as well, where we had to have a ground man go up there and scrape those chutes down from every once in a while, about once an hour. Some of the things that we've tried over the years to help improve that is you can mix a little bit of sand in with your shingles to help them feed better. The important thing there is to make sure that you're accounting for that in your mix, so you don't put too much sand in your mix. So that has worked. We also, for a while, we used our cold feed bins on our plant, and we pre-blended our wrap and shingles together because we only had one cold feed recycle bin on the plant at that time. And that seemed to work out well, and then we had a pile of wrap and shingles already blended together. The problem with that is we had a couple contractors, or at least one, that were using that system of blending. They were putting too many shingles in the mix and taking wrap out or taking virgin aggregate out. And so they were putting a lot more shingles in the mix than was allowed by specification at that time. And so MoDOT said, okay, we can't do that anymore. You're going to have two cold feeds for your shingle, one for shingles, one for wrap, so they can see what's being fed into the plant. But like I said, if the trust level is there, then you could blend that together and feed it through your plant. So there's some additional costs there. Like I said, we wound up we fabricated two cold feed bins, one for shingles, one for wrap. Most definitely, you're going to have some kind of vibrator or air cannon on the shingle bin. When you feed that in, that you've got the pressure of the weight acting down the shingles, it'll want to compress those down in the bottom of the bin. So we have air cannons on most of our bins there. We also have small vibrators on some of them as well. You're going to have your control system and making sure you have enough space in your system to add another card to control that other cold feed. And like I said, we put covers on our conveyor belts. You are going to have to add some stuff there as well. And there's going to be some equipment cost. If you're taking these shingles in to process yourself, then they're going to come in by dump trucks, so you're going to have to, push them up. But the thing is the nails and everything are in them at this time, so we have a tracked dozer that we push up our stockpiles with, and then we try to clean everything up then with a broom, just so we don't have to buy pickup truck tires all the time with nails sticking in them. So on the left is our wrap bin, and on the right is our shingle bin at our Sullivan plant. We put those little wings on there as well because the shingles, like I said, they have a lot of moisture and they tend to want to stick together, kind of like wet sand, so it will kind of build up. So we put those wings on there just to keep the shingles from sliding off the edges of the bins. When you start this process, your loader operator, like always, is going to be very important, making sure that they blend everything back together and keep a consistent feed going. Talk a little bit on this. We have a real concern about the cold weather kind of fatigue issues that are associated with the shingles, and we've had some issues with this in the past. We're trying to get a handle on this in Missouri, but if you're looking at where your grade is already like a 64 minus 16, but you're using a 64-22, and it may not be an issue. So one of the other benefits of the shingles is there's usually like a granite or basalt on the shingles for the aggregate that's on there. Well, that's what we always had to haul in to use as a sweetener in our mixes to get our VMA higher. So you're already putting those in there, and especially for fine mixes, you're putting them in there at that 150, 30 kind of size, and so you're building VMA in your mix as well. The shingles we've also used in our mixes now. We do not see rutting in our roads in Missouri very often at all anymore. Those shingles are also helping tie that road together. So our biggest problem now is in the oil part of it with the fatigue. So we start with a clean shingle supply. Like I said, grinding them down, you want to grind them fine, and they will release more oil, dissolve in the mix easier. And I'll show you some pictures here on the sizes, how they've changed over the years. But one of the problems that we had was with these pop-ups. When we were grinding them to about 3/4 of an inch size, those shingles, some of them would get all the way through the mixers as a full tab there, about 3/4 of an inch size. And they would be on the surface of the road, and when the rollers went over them, they would pop up and stand up on the road. And it looked like, your road needed a good shave there. So we went through then and started grinding them smaller, and that took care of that. The only issue on the there's a couple issues with the pop-ups. Number one, you did your mix design expecting all that oil to be available in the mix. So if your shingles were too large, you weren't getting that. The other thing was I talked to another contractor, and they did a residential neighborhood, and they had those pop-ups. And there was a lady that called them, and she was very upset because those pop-ups, they would get ground off or torn off by traffic, and she had them on her driveway and walked through them and then walked into her house. Well, she had all white carpets in her house. So that was the first time I ever heard of a contractor being called to come do a carpet job inside somebody's house. But like I said, the more you grind them, the better off you are, except for if you get them down too low, then too small of a size, like I said, the wind's going to start blowing them away. So that you grind them finer. The other thing is you have more surface area, so they're going to hold more water. Talked about the wind, and I talked about the pile crusting over. This is when we started looking at shingles in 2003. This was a landfill that was accepting shingles. You can see they are not very clean at all, and that's what was happening is when you have a roofing contractor, they throw all their soda cans and McDonald's wrappers and beer bottles and everything else in there. Also, they were throwing the wood. If they were doing having to repair the deck on a house, they would throw that wood in there as well. I know the first load of processed shingles that we got had a 4x4 in it, about 3.5 foot long, and I didn't think that was too good a quality control on that. But and they also did all this separation by hand, so it was very labor intensive. So these are kind of the deleterious materials that you'll see in there. The finer you grind this, the less of this that you'll have, or less of it will be an issue. The cellophane stuff will typically dissolve down in if it gets into your plant, and you won't see it. You're going to get a nail in there every once in a while. Just some of the newer nails are made out of an alloy, so the magnets won't pick them all up. But when those nails go through your plant and everything, they're going to be hot, and they're not going to be on the surface of the mix very often, and if they are, the rollers are going to pound them in, so they're not really that big of an issue. Like I said, you got to, I'm not saying you have to leave them all in, but there's a few that get through. It's not really going to be an issue. One of the interesting things about the fibers that are in these shingles, if we do a burn off in our NCAD oven, then those fibers are there in the gradation, and they do not dissolve or they do not burn up even at like 1,000 degrees. So that's kind of one of the things, that those are residual in the mix as well, and helps build your rutting resistance. This is kind of how we collect them now. You'll still get some cellophane wrappers and things like that every once in a while, but we've gone to working with our shingle contractors and educating them on what we need, because if they have to take these shingles to a construction landfill, it's $100 a ton right now. So they are very willing to work with us and give us a clean shingle pile. The other thing is, if we have some people that don't follow the rules, then we tell them they can't drop them off there anymore. So this is kind of an idea of what the pile looks like, kind of a little bit closer. You said you will get a few of those cellophane wrappers, and what we do is, while we're feeding them in, we'll have a couple guys just kind of peeling off all the cellophane that we can, because the grinder doesn't want that in there, because it wraps around the augers on the grinder, and then you have to shut down and peel them all off. So we try to pull those out as we go. This is kind of what I was talking about with the pop-ups. These were a little bit larger size shingles back in 2005. Like I said, we were getting those tab pop-ups on the road. We weren't getting as much oil into the mix, even though we were designing the mixes with a full amount of oil. So these were the largest particles that I could find out of a handful of stuff in 2008. And then we kept going smaller here. This was in early 2010. That's what the shingles look like. There are contractors in Missouri that grind them even further than that. They're getting down to about a number 4, a quarter-inch size on their top size. So this is 2010 shingles, just a little bit finer grind there as well. And that's our stockpile. You can see kind of what it's talking about on the top of the pile there. You're getting some bigger pieces that are crusting over. So just make sure the loader peels those out. You can smash them back up. Like I said, too, those gators or a device like that will grind that back up if you want to put one of those on your plant. But for the most part, the shingles stay fairly well ground and perform very well. And just so you know, when we started putting shingles in our mixes in Missouri, we didn't start at our commercial mixes and work up to super pave. We started with super pave mixes as our first attempt. And in Missouri, we brought in super pave, quality control, quality assurance, and pave factors with percent within limits all at the same time. So when we did this, we were gambling on our biggest potential for disaster with pay deducts and removal and things like that. Some of the other things that we get, pay adjustments they call them, is tensile strength ratio. We can get a bonus or deduct or removal just based on that. We have a smoothness system as well, where we can get a bonus to a removal on that as well. And our unconfined joint density is very, very strict. The air voids, VMA, AC content, density are our pay factors. They're weighted 25% apiece. We could have a bonus on those and our unconfined joint density fail, and we would have to remove the lane or go back through and cut that unconfined side off and then lay next to it on a confined joint on the next lift. That was one of the big problems that we had in Missouri, was our pavements failing at the joints. So Missouri put a very strict deduct on that as well. now we're starting to get a handle on that. We're looking to try to get a bonus, but shingles will tend to make your mixes a little stiffer, a little more difficult to compact, so that was one of the other issues we had, was making sure we maintained our density all the way across the map. Right now in Missouri, we cannot use shingles with polymer modified asphalts. So we've tried a couple jobs, and I've got one example here that we did. But these types of oils is what is allowed in Missouri right now, polymer modified, and we typically don't see those oils used with shingles. We wanted to know how it works, so I proposed to MoDOT a change on this job that we had. This is a what we call an 095 mix. It's a 9.5 millimeter. C is a moderate level of traffic. This is a state highway route. It's not an interstate. We proposed using a 70-22 polymer modified asphalt, 4% shingles, 11% wrap, and this mix was laid an inch and a quarter thick. On this section here, we also did a 190C mix, which is 19 millimeter binder cores. This section was heavily rutted, so we milled some out and then built it back up. That mix also had 2.5% shingles and 7.5% wrap in it as well. And this was one of the intersections on this job. It's a very high traffic intersection. It's an intersection of two state routes, and it's laid about an inch thick due to the geometrics of the intersection. It was a very thin lift, and I would say kind of towards out in the middle there where you can see the heaviest cracks, it's probably closer to 3/4 of an inch thick. So it is cracking. It started cracking probably about 8 months after it was laid. That was a concern, and I talked it over with the MoDOT folks, and they were kind of, our agreement was, yeah, this probably would have performed better with a 64-22 oil or a 58-28 oil, but also laying it that thin, you're bound to get those reflective cracks back in. They said their rule of thumb was about a year per inch of thickness of mix, and so they weren't too alarmed by this. And this is actually the worst place on the job. This was back in that first picture I showed you on this job. This is where we milled a couple inches and put the 19 millimeter mix down and topped it with this 9.5 millimeter mix with the polymer modified oil. This section is not cracked as bad as the other section. You do see occasional crack in it, but performing very well. If it was the oil and the shingles hardening it up and making it very stiff, then you'd expect to see this cracked as well. It's been through a couple winters now, and the cracking issues are about the same as with another mix with a different type of oil. But and I think a lot of that you're just going to have to, when you're going to design the road and what mixes that you're going to use, you have to realize that if you have an issue there with fatigue, you may not want to use a polymer modified oil with shingles. So some of the things that we've kind of ran into in Missouri is when we started, everybody was kind of running around 3% shingles. You might do 17% wrap, 3% shingles. Well, then as it got more and more accepted, and people, our budget in Missouri for MoDOT has gone from $1.2 billion in 2010 to $600 million in 2012. So we've got about half as much work out there. So people are trying to be cut costs. So last year we had a couple issues where some people tried to jump up in that 8 to 10% shingles, as well as wrap in the mixes, and we had some issues there with some roads falling apart as they were being constructed or shortly thereafter. So there is a limit on shingles. It's not a cure-all. That is something you have to be aware of. Then the other thing is wet weather. We had a very wet spring, And like I said, we switched over to warm mix, and we use Evotherm, and that allowed us to, the Evotherm uses some of the residual moisture in the aggregates to work, so we were able to continue paving in the wet season, and we actually got our work done on time. There was a lot of contractors in Missouri that had to carry jobs over this year due to the amount of rain and things that we had this year. We've also done cold weather paving with shingles, and we've paved a job with about an hour haul. It was a couple days before Christmas, and it was 14 degrees that morning, and we were still able to make mix with the Evotherm. Now, we did not drop the temperature down to 250, but I think we made it about 320 degrees that day, which is well below the 350 we probably would have ran if we didn't have Evotherm in there. So things that I've said, I said shingles wouldn't work, and I also said once we went to warm mix, we wouldn't be able to use shingles anymore. So I'm 0 for 2 on being right on that. One of the big issues that we've got in Missouri is designing the mixes too dry. People are trying to make the cheapest mixes possible now and put too many shingles in them. One of the big issues I need to talk about a little bit there is when we started putting shingles in the mixes, we thought that we had to really run the temperatures up. A lot of times we were trying to make mix at 360, 370 degrees, and MoDOT has a specification, 350 degrees is their maximum temperature of their mix. And but the big problem there is, except we had those 3/4 of an inch size shingles, and we were trying to get those dissolved down. Well, we were trying to use heat to do that. What we needed to do is do the grinding, and now we do not have issues with our shingles getting dissolved into the mix. You can debate a lot on do we get 100% blending of the oil and those kind of things. And guys a lot smarter than me have to answer that question. But like I said, you do not really need to run the temperatures up to get the shingles to dissolve. We had a new contractor last year, or year before last. First time they were using shingles, and they were trying to make mix at 390 degrees. And they burnt the mix and then had to set in with the milling machine and take it all out. And that goes back to using the coarse shingles. Finer grind is good. Like I said, shingles are great, but there is kind of a limit, and the quality control folks, mix designer folks, are just going to have to decide what's going to work best with your aggregates and where you're at and those kind of things. We do have contractors that run 7% shingles every day, and they don't have issues, but they are doing a lot of homework and grind size, and their plants are optimized and those kind of things. And like I said, rut resistance has been improved in our shingle pavements, but the fatigue and cold temperature performance are things that we're still looking at and debating in Missouri. And like I said, we've had very good luck with Evotherm 3G and shingles. So if you guys are interested, you can always send me an email. We've got some information on our webpage as well. We've got a couple of videos on there that MoDOT came down and did with us for shingle recycling. So if anybody has any questions, send me an email. And besides that, if there's any other question you guys have, just let me know.
Steve, we appreciate you doing this presentation, and for everybody else's, just kind of his back information, he did a very similar presentation at the Mississippi Quality Asphalt Conference a few weeks ago, and it made a really strong impression on me because I don't have any personal experience with shingles, and that really is why he and I struck up a conversation afterwards, because I think this is a lot of good information. Do y'all have any questions there at the test track, or Richard, do you have any questions at the main office? Well, Richard has asked a question. He sent me a message, and he says, does MoDOT use the AASHTO shingle design, or do you assume 100% binder contribution from the shingles?
Actually, Joe Schreier at MoDOT was one of the big, I don't know, contributors to that AASHTO spec. And yes, we've kind of gone back and forth on that. What's happened, and I'll give you the straight scoop here, is when you assume a factor on there, and we actually had a spreadsheet that I showed in that Mississippi presentation to that would calculate that factor, and our spec in Missouri doesn't say you can use X% of wrap or X% of shingles. That originally, that's what it said. It limited your shingle usage to 7%. But what we've done now is we've gone to an effective binder replacement, and 30% effective binder replacement is what you can do without changing your grade of oil. You can go between 30 and 40% effective binder replacement, but you have to go to a -28 oil that due to the fatigue. You can actually go past that point if you do the blending charts and some cold weather testing type tests. But what happened then is calculating that effective binder replacement. If you put a factor on that, it basically allows the contractors to put more shingles in the mix with less virgin binder. And we've had some, like I said, we've had a few instances where our, not our super paved mixes, but our everyday mixes that we put down for MoDOT on lettered routes, those were having problems sticking together. And by assuming 100% contribution of the shingles, it's basically forcing the contractors to put more virgin binder in the mix. So last year we used the AASHTO method. This year we've gone to assuming 100% shingle utilization of the oil, and that's where we're at on that.
Richard says thanks. There's got to be some questions there with you guys in the conference room at the test track now. Is there anything you want to ask Steve to kind of pick his brain? They sort of built their operation through trial and error from the ground up there at their plants, and do y'all have any questions for him while we got him online?
We have a question as far as feeding the rats into the plant. We've heard, an auger system. There's been some discussion about that, and then there's also, just belt feeding, and what is experience with either of those two methods?
The cold feed is probably going to be your best bet there. These shingles, anytime you start getting heat on them, they're gonna start getting sticky. So an auger there, when you're pushing on them, you're more likely going to be able to get them where they start sticking, and you're going to have your build up in your auger. And the other thing is controlling your feed from a quality control aspect of it. We have slowed down. We've got a variable frequency drive on our recycle bins, so we can control that very well. But from my experiences, especially around some of the wrap collars and issues that we've had there, I would say your cold feed bin is going to be your best bet on controlling your quality, and also not having problems with things binding up on your plant.
Thank you.
Any other questions for Steve? All right, well, Steve, we sure do appreciate your time. This is very interesting stuff, and we'll, all of us, I think, will be sure and follow up with you if we think of anything after the fact. But thank you very much for doing this.
You're quite welcome.
All right, I'm going to end the meeting unless anybody has an objection to that.
No, we're good here. Thanks, Steve.
You're welcome.
All right, everybody have a great day.
Thanks.